Hello, pre-calculus. We are starting chapter 2 today, and chapter 2 starts out with a review over quadratics. Quadratics meaning those parabolas, those U-shaped graphs. We did those at the very beginning of the year in chapter 1, and you did a lot of quadratics in algebra 2. So today should be just a really good review over different parts of quadratics. There's this box here at the top that has different forms. We're first going to talk about vertex form. I'm going to get to that in a second. And then we'll start talking about quadratic form and intercept form as well. You should have covered all of this in algebra 2. So again, this is going to be a review. With vertex form, to find the vertex, I've told you HK. So you look at your vertex form, whatever's in this spot and whatever's in this spot becomes your vertex. The axis of symmetry is written as X equals H. That's as far as we're going to get today. We're just going to go through vertex and axis of symmetry. Quadratic form is ax squared plus bx plus c. And the axis of symmetry would be the thing that you find first. I also set this up in like the order that you would find things. But the axis of symmetry is what you would find first. And that would be x equals, and then you do negative b over 2a. That's your axis of symmetry. To find the vertex, you plug that in for x, and you solve for y, and that's your vertex. And then intercept form is actually factored form. So if you ever want intercept form, you can if it factors, you can factor it, and then it will be in intercept form. And in an intercept form, we will set each of our factors equal to 0, and we'll solve each factor, and you'll get those p and q values. We're going to average those to find the middle, and that would be your axis of symmetry. X equals the middle of P and Q. And then the vertex, you will take that X value, you will plug it into the equation, and that will give you the Y value. I'm going to review all of that when we do examples, so don't feel like that's all you get. You'll get some down below with actual examples. We're going to start with vertex form first. And one reason why we're starting with vertex form is because when it is in vertex form, we can find transformations. And again, we did this in chapter 1. We did lots of transformation review. So we're going to do some more transformation review today. So when it's in vertex form, the vertex is the H and the K. But the H and the K are also transformations. The H is a horizontal translation. The K is a vertical translation. Translation meaning sliding. So like H would go left or right, K would go up or down. And then the A value is, it could be a reflection in the x-axis if it's a negative sign, or a negative number, sorry. And, or we could have a vertical stretch or shrink. Like a stretch would be a number that's greater than 1. A shrink would be a number that is between 1 and 0. Now, there's one more thing that vertex form does not have, but we were using when we were doing transformations. If there's ever a number in front of the x, it has to be factored out. So inside of that parenthesis that's squared, you would have this number b, and then we would have that x minus h. The a is in front. Oh, I'm not going to write the a. I'm just going to put that part right there. Okay, so but this b value, that would be a horizontal stretch or shrink. And when we talk about horizontal, we need to remember that anything horizontal So horizontal transformations use the opposite operation from the equation. And we'll have some examples below about that. But just remember, horizontal, we always have to go with the opposite operation. Vertical, we just use the same thing. So we are going to practice, review some graphs. All of these are in vertex form, so we're going to do these with transformations. Now I'm asking you to make a transformation table. You do not always have to make a transformation table. We're doing it for notes so that we have practiced. For sure, I would not need a transformation table for number or letter A. That one I can easily just transform using the graph itself. But sometimes they get more tricky. So we're going to make sure we know how to do the transformation table. And then we're also going to write down our vertex and our axis of symmetry. And then I skipped this part, but describe the transformations. So let's, first of all, I'm going to go ahead and graph the parent function of just f of x equals x squared. You do not have to do this every time either. I'm just doing it for like the first couple. So we always have 0, 0 for parent function. And then when I plug in 1 and I square it, I get out 1. When I plug in 2 and I square it, I get out 4. I plug in 3 and I square it, I get out 9. And then quadratics are symmetric. And if I plug in -1, I also get out +1. If I plug in -2, I also get out +4. And if I plug in -3, I get out +9. So that takes us through the graph. And I'm just dashing this because it is not the answer to the question. It's just a parent function that is going to help me find the function that they want graphed. So then I'm just going to write those ordered pairs down of the parent function to start our table. So I'm using from -3 to -3 to +3 on the x's. And then on the y's, we square all the x's. And now we're going to look at transformations. So this 3 is inside of the squared, which means it's horizontal. That is a translate 3 units. And since it's minus, it's going to be right. And then over here on the outside of the squared, we have a vertical translation. 4 units down. So then we go to our table, and anything that is horizontal will go on the x side of the table. So that 3 units right means +3 to my x values. So the words in the table match, the equation will not match. The words in the table match the horizontal stuff. So I'm going to add 3 to each of these. And then I'm going to go over to my y side, and I'm going to subtract 4 from each of these. And when we do that, we've created ordered pairs, 0, 5, 1, 0, 2, -3, and so on. We're going to graph those ordered pairs for our new function. That was yucky. I got to fix that one. Okay. Now we have to answer the questions like, what's the vertex? And there's 3 places I can find the vertex right now. This is in vertex form. So I should be able to look at the equation, take the opposite of -3, which is 3, and take the -4. And there I have my vertex. Second place that you can look for your vertex is in your table. The original vertex is at 0, 0. So when I transform that original vertex, it becomes the new vertex of 3, -4. Oops. And then the third place that I can find the vertex would be to look at the graph and look for that one point that does not have a mirror. That would be your vertex, which again is at 3, -4. The axis of symmetry is that line of symmetry that passes through the vertex, through the center of your parabola. It is always x equals, and it always uses the x value of the vertex. So if I have the vertex, I can easily find my axis of symmetry by taking the first number. But you do need to put x equals because it is a line, not just one number. It is a line. Okay, and that's all we have to do for this one. I'm going to pick up the speed a little bit because I did all my explaining. I'm just going to go through these examples. If you don't need all the examples, try them on your own and then check your answers with mine. Oh, geez. Okay. So the first thing I'm going to do is write my transformations. The negative sign out front tells me I'm going to have a reflection. We talked about this in chapter 1 a bunch too. This is a vertical reflection, and to reflect vertically up and down, I need to reflect in the x-axis. Then we've got 2 translations. I've got a +2 right here, which means that I'm going to translate 2 units left and 5 units up. Okay. My stylus just turned off. Oh, there we go. All right, so we wrote down our transformations. Now I'm going to make a table. And I'm going to use -3 to 3. And then for transformations, if we have anything horizontal, it goes on the side of the x. So I've got 2 units left, -2. And then anything vertical goes on the right, but we have 2 vertical things. So the rule is go in the order of operations. So I'm going to multiply by -1 first, then I will add 5. All right, so then if you had your original graph, which I didn't graph yet, I'm going to do that real fast. Maybe I'll go ahead and find my vertex also. Okay, so looking at this equation, the vertex would be at -2, +5, which means my axis of symmetry will be at x equals -2. So I'll graph my axis of symmetry at x equals -2. My vertex is at -2, -5. No, at -2, 5. Sorry, something didn't seem right. At -2, 5. And then we can graph ordered pairs. Or since there wasn't a stretch or a shrink on this, I can actually just follow the pattern. Follow the pattern of how far the points are spaced. And then we have our graph. Okay, the next one doesn't look like it, but it is in vertex form. This would be a vertex form that would look like 2 parentheses x minus 0 squared plus 4. That tells me that my vertex is at 0, 4, which means my axis of symmetry is at x equals 0. My transformations, the 2 in front is a vertical stretch. By a factor of 2. And then the plus 4 would be a translate up 4 units. I'm going to make a table. And I'm going to apply my transformations. Both of these transformations are vertical. So I need to make sure that I do the multiplication before I do the addition. Now, this is not going to fit on my graph unless I number my graph, if I scale it differently. The minimum points that I need you to graph must be 5 points. Okay. Minimum points graphed is 5. So you either need to change your scale so that you can fit 5 on there, or for this one, I'm just going to, like, I've got some 12s, so I'm just going to go like that and make it go up to 12. And that way I'll have 5 on it. Let's see, I've got my vertex at 0, 4. And then my ordered pairs around that would be -1, 6 and +1, 6. I'm just getting these from the table. -2, 12 and +2, 12. This one's stretched vertically, so it's skinnier than the past 2. And then there is an axis of symmetry right here. So everything's symmetrical around x equals 0. If you've been listening to me do each of these, sorry, excuse me, you should try to do it on your own and then check your answer. You can easily pause the video at this point to see if you can do it on your own. So transformations for this one, we've got a 1/3 in front. That is going to be a vertical shrink by factor of 1/3. And then the -6 on the inside is going to be translate 6 units to the right. Okay, I can make a table. And the vertical is multiplying by 1/3. And then my horizontal is adding 6. So if I multiply, or if I add 6, 3, 4, 5, 6, 7, 8, 9. And here, if I multiply by 1/3 divided by 3, this is a 3. Then we've got 4/3, and we've got 1/3, 0, 1/3, 4/3, and 3. So I've got 3, 3, 4 is 1 1/3. 5 is 1/3. 6 is 0. And then we've got our mirror points. There's an axis of symmetry right here in the middle, and we've got our vertex. Our vertex is at 6, 0. Our axis of symmetry, x equals 6. And then I've got 5 points, so I'm just going to do the best I can to connect that through the rest of the graph. Okay. That's half of what you're doing for your assignment. And then the other half is finding the axis of symmetry and the vertex for just given equations. You don't have to graph. You don't have to do a lot of work, just axis of symmetry and vertex. This, in our notes, we're going to state which form the quadratic is in. So this is where you're going to need to know, going right back up to the top, you're going to need to know which form it is, so you know how to find the axis of symmetry and how to find the vertex. It differs between each form. So I'm not going to keep going back up to this. I'm just going to write the formulas as I'm doing the questions. And for you to memorize them, it is helpful for you to write the formulas as well. So we're going to start out with this one, and this one is in vertex form. So to find my vertex, I'm looking at the h and the k value. And I do the opposite of the -4. So we have +4 and then 5. That would be our vertex. And then the axis of symmetry is x equals whatever the vertex value of x was, 4. It's the h value. And that's it. That's all I have to do for question A. Question B is now in quadratic form. So this is the equation that's ax squared plus bx plus c. So we've got an a and a b and a c, and those are numbers in front of the x's or by itself on the end. To find the axis of symmetry and vertex, you are going to start with the axis of symmetry, and you will use the formula that says x equals negative b over 2a. So in this equation here, I'm going to do negative, and then I'm going to find my b value, which is a 1, over 2 times my a value is a -1. So I get a -1 over a -2, which simplifies to x equals 1/2. So that is the axis of symmetry. To find the vertex, the formula says to make it a ordered pair. And then negative b over 2a is the x part of that ordered pair. And then the y value is f of negative b over 2a. And what that means is it means replace x with negative b over 2a, which we have the answer for right above, and evaluate to find y. I should write replace x, that means in the function. That's where we're replacing in the function right here where there is an f of x. That's where we're going to put it. So I'm going to do, instead of f of x, I'm going to do f of, and my negative b over 2a is a half, equals, I'm going to copy the minus sign. I'm going to put parenthesis, a half, close parenthesis squared, plus, I'm going to have just a half, and then minus 4. So I plugged in a half every place there is an x. And I get, by order of operations, negative, and then square that 1/4 plus 1/2 minus 4. I'll go ahead and make a common denominator with all those. Negative 1/4 plus 2/4 minus 16/4. And then common denominator is 4, add the numerators, and I get negative 15/4. So my vertex is 1/2, comma, negative 15/4. So we have our axis of symmetry and our vertex. You can see that doing the axis of symmetry and the vertex when it's in quadratic form is a lot more work than it is when it's in vertex form. So in the future, we will actually be able to change from quadratic form to vertex form because vertex form is so much easier. But that will be Friday or Thursday and Friday. Okay, now we've got our last example, and this is intercept form. Which I like to call factored form. And this one we're going to do a lot of work with in this chapter, intercept form. So when we have intercept form, to find the axis of symmetry, we actually need the x-intercepts first. And to find the x-intercepts, we set each factor equal to 0. So my factors would be negative 3, x minus 9, and x plus 15. In every place that we see an x value, we're going to solve. So this first one doesn't have an x value in it. That will not give us an answer. The second one, I'm going to add 9, and I'm going to get x equals 9. And then the third one, I'm going to subtract 15, get x equals negative 15. So I have my x-intercepts happening at 9 and negative 15. So if we had a graph and we had like 9 here and negative 15 here, and those were the x-intercepts, and I've got a parabola. Actually, it's negative parabola. Hold on. It's that way. If I've got a parabola that passes through, then the axis of symmetry is going to be somewhere around here. Somewhere right around here, which would be the exact middle between 9 and 15. So we average the x-intercepts. And that's how we're going to find our axis of symmetry. So we'll take our x-intercept, the first one, plus the second one, divide by 2. And I forgot something really important. X equals is how we're going to write it. So let's see, 9 plus negative 15 divided by 2 is negative 6 divided by 2. So our axis of symmetry is x equals negative 3. And then to find the vertex, we're going to do the axis of symmetry in the x place, and then we'll do f of our axis of symmetry in the y place. So we need to plug in negative 3 into the equation for the x's. I'm going to change colors because I'm getting mixed up with what I'm doing right now. So f of negative 3 equals negative 3 times, and then we've got negative 3 minus 9, and negative 3 plus 15. So I'm plugging in negative 3 for x. Get negative 12. I'm going to get positive 12. Negative 144. It's going to be positive. So I got 432. So my vertex is written as negative 3, 432. And then the next thing says day 2, so we are done with today's notes. Your assignment is a worksheet. The worksheet is non-calculator. The worksheet is non-calculator. You will notice that I did not take out a calculator at all. I actually hand multiplied out that last one. So make sure that you're not using a calculator. You can use your calculator to check your answers, but not to get your answers. If you have any questions, log on and ask. I am here to help you. Have a great day.